Hello everyone. Once again, welcome to my channel. Uh, we are starting with next question, that is 1.7 of class 11. Uh, the question states that how much copper can be obtained from 100 gram of copper sulfate CuSO4, right? So to solve this question, we should know that 1 mole of copper sulfate contains 1 mole of copper. Okay, so if we say that, then what is the molar mass of copper sulfate? So as we already know that molar mass of copper sulfate can be calculated. Okay, mass of copper metal is 63.5 grams, plus sulfur is 32 grams, plus 4 into oxygen is 16 grams. And when we calculate it, it becomes 63.5 plus 32 plus 4 into 16 is 64. And we add it, it becomes, we are adding from the back. So yes, 0.5 is written like this. And 3 plus 2 is 5 plus 4 is 9. And then there is 6 plus 3 is 9. 9 plus 6 is 15. So 159.5 grams mole inverse. So this is the molar mass of copper sulfate. So from this particular thing, we got to know that if 159.5 gram of copper sulfate is given to us, then it contains 1 mole of copper, that is 63.5 gram of copper. Okay. If 1 gram of copper sulfate is given to you, then it is 63.5 divided by 159.5, right? Gram of copper. And in the question, we have been asked for 100 gram. So for 100 gram of copper sulfate, it is 63.5 divided by 159.5 multiplied by 100 gram of copper. You can calculate it. It can it will actually comes around to be 39.81 gram. Okay, so this is how you solve this particular question. Next question is 1.8 from the exercise. Once again, determine the molecular formula of an oxide of iron in which the mass percent of iron and oxygen are 69.9 and 30.1 respectively. If you remember, we have already done this question in the previous videos. But once again, I can take you back and then we can do it. Okay. So what is given to us, which we haven't given, mass percent of iron. Right, iron is given, that is 69.9%, and mass percent of oxygen is also have been given, that is 30.1%, which means if we take that 100 gram of oxide of iron oxide have been given to us. Okay, so in this much iron oxide, we have 69.9 gram iron and 30.1 gram oxygen. Okay. We have to calculate number of moles of iron and oxygen over here. So we will calculate the number of moles. Number of moles of iron will be given mass of iron, which is 69.9, divided by molar mass of iron, which is approximately 56. You can also take the exact value, that is 55.85. Okay, you can also take 56, that is also correct, which comes out to be 1.25. If we calculate the number of moles of oxygen, then there is once again given mass 30.1 divided by mass of oxygen is 16. Okay, so then we can calculate it. It comes out to be 188. Okay, these are number of moles, so you can also write it down mole. Okay. Next we can calculate, we can convert it into the ratio. So ratio of iron to oxygen in the iron oxide. Okay, we do not know that which oxide is it, but we can calculate. We have to take the iron is to oxygen ratio, which is Fe, and oxygen ratio 125 is to 1.88. Okay, 1.25 into is to 188. What we can do is we can divide it from the lowest number. So we have the lowest number, which is 1.25. We can divide both iron and oxygen's ratio from 1.25. We divide it by 1.25. It comes out to be equal to 1. And this oxygen ratio comes out to be approximately 1.5. So iron ratio is 1 and oxygen is 1.5. But we know that an amount can never be in decimals. So what we have to do, we have to convert it into next whole number by multiplying it with something. That number is going to be over here 2, because when 1.5 is multiplied by 2, it becomes 3. So on both sides we are multiplying it with 2. So iron's value become 2 is to 3. So the ratio of iron and oxygen is 2 is to 3. That means the empirical formula for iron oxide is going to be Fe2O3. So this is how you will calculate the questions where we have to depict the empirical formula of iron oxide or any kind of compound. Going with the same question, the question also asked for the molecular formula. For calculating the molecular formula, we should know that what is the molar mass of empirical formula. So mass of empirical formula is going to be, iron is approximately 56, right? And or you can write down the exact value, that is 55.85, plus there are 3 oxygens, that is 16. Okay, and when you calculate, it comes out to be 59.69 grams approximately. Okay, so what we have to calculate after this, we have to calculate the n factor, which has to be multiplied in empirical formula to convert it into molecular formula. N factor is mass of empirical formula, which is 159.69, divided by its molar mass. Obviously, we know that iron oxide is this one. Iron oxide is ferric oxide. Sorry, ferric oxide. Okay, why? Because iron has 3 oxidation state over here. So it can also be said as iron 3 oxide. It has molecular formula that is Fe2O3 and its molar mass is 159.7, which is approximately equal to 69. So it is approximately 1. So if n factor is 1, then molecular formula is equal to n multiplied by empirical formula. So n is 1 multiplied by empirical formula was Fe2O3. So the molecular formula becomes Fe2O3. So this is how you will calculate the molecular formula. Okay, now we are going to do the last question, which is 1.9. Calculate the atomic mass, average atomic mass of chlorine using the following data. If you remember, this kind of question we have already done in the class 9th also. So we are going to use that formula over here. So we have to calculate the average atomic mass. Okay, the average atomic mass of anything, you know, it has a formula that its percentage natural abundance will be multiplied by the molar mass of isotope 1. Okay, we are talking about percentage natural abundance of isotope 1. It is multiplied by molar mass of isotope 1 plus, once again, percentage of isotope 2 multiplied by molar mass of isotope 2 plus so on. If other isotopes are there, then we will do it like this. So over here, percentage natural abundance for first isotope, which is chlorine 35, is 75.77%. Okay, it is percent. Percent means divided by 100. Multiplied by the molar mass is given, which is 34.9689. Okay, plus percentage of other isotope is, the second isotope is 37, which is 24.23%, means once again 100 multiplied by 36.9659, which is its molar mass. So when we calculate it, okay, you can calculate it. I'm using the calculator. Okay, so you can calculate. It comes out to be this much, comes out to be, I think, 26.4959 plus this comes out to be 8.9568. Okay, when we add it, it becomes approximately 35.4527 units. Okay, which can be, seen that the average atomic mass of chlorine, which is naturally present, okay, is 35.4527 units. So this is how you will calculate the average atomic mass. I hope you all have understood how you have to calculate these particular questions. For next time, we are going to hopefully take more questions. So thank you so much and have a nice day.